amines, है ना? Right, next. This is the sixth reaction, I guess. Fifth one is reaction with nitrous acid. Right, the sixth one, basic character. Now, amines, they show basic character because of the lone pair that is present in the nitrogen atom. We have RNH2. We have RNH2 plus H2O. That is in equilibrium with, rather when it is going to react with H2, it is going to give you NH3 with a positive charge on nitrogen atom, and OH negative from the water molecule will be released. So due to the presence of amine, the concentration of OH negative is increasing. Huh? And that is why it is acting as a base. Now, how is the concentration of OH negative? Because it is able to attack on the H plus ion. So you can write here amines abstract H plus ion due to the presence of lone pair electron, presence of lone pair electron on nitrogen atom. Therefore, amines are Lewis base. Because they're able to donate electron pair, they are what? We call them Lewis base. After this, you'll write the Kb for amines, it is equal to the concentration of RNH3 positive into OH negative divided by RNH2. We don't take concentration of liquid in the equilibrium constant reaction. Now, since this is Kb, that is the dissociation constant of a base, and as the concentration of OH would increase, the numerator is increasing, and that is why the whole value will also increase. So we can say that strong bases, a strong base have higher value of Kb. ठीक है? डिसोसिएशन कांस्टेंट ऑफ बेस, अगर आपके पास स्ट्रॉन्ग बेस है तो डिसोसिएशन कांस्टेंट ऑफ बेस भी क्या होगा? ज्यादा होगा. नाउ next thing is the relationship between Kb and pKb. You also know that pKb, P means power of, and that is equal to minus log of Kb. Now, if Kb is higher, if the dissociation constant of base Kb, if this is higher, then log Kb will also be higher. Okay, this log Kb. But if log Kb is higher, the minus log of Kb will be lower. Because if you are adding a minus sign here, तो सारा वैल्यू कम हो जाएगा, है ना? फॉर एग्जाम्पल 7 और 8 में कौन बड़ा है? तो 8 बड़ा है. बट -7 और -8 में कौन बड़ा है? -7 is greater than -8, है ना? So in that sense, minus log Kb will be lower. And what is minus log Kb? It is nothing but it is pKb. So Kb is higher, then pKb is lower, and that is why we will say strong base has lower value of pKb. Please write this down. Raise your hand once you're done.
Assalamualaikum sir.
Aslan, take a screenshot from here.
Okay sir.
क्या और आपका सारा प्रैक्टिकल हो गया खत्म? ये सर सलाम।
नहीं सर, मंडे में मेरा एक और बोर्ड एग्जाम होगा, अभी प्री बोर्ड एग्जाम।
अच्छा, एक और प्री बोर्ड है। अच्छा, प्री बोर्ड चल रहा था ना आपका? केमिस्ट्री हुआ?
जी हो गया।
कैसा गया केमिस्ट्री?
केमिस्ट्री ठीक ठाक गया था।
अच्छा, हमें आप भेजेंगे क्वेश्चन पेपर?
जी ठीक है। यस सर, आई एम डन टेकिंग स्क्रीनशॉट्स।
हाँ, you're done taking. ठीक, I'm just waiting for Krishna Priya. Krishna Priya, you'll raise your hand once you're done. Okay, fine. ठीक, now you guys can lower your hand. Now, since amine is a lowest base, all the basic character it is present in amines because of the lone pair on nitrogen atom. Now, we will be comparing the basic strength. And when we compare the basic strength, we will also take into consideration when nitrogen it is bonded with all three are what hydrogen atom. So this is ammonia. This is what? This is ammonia. Then we have the other one that is primary amine. That means R. It is having three bonds, and two of them is hydrogen, and one of them is alkyl group. Please don't write now. ठीक है ना? ध्यान से सुन लीजिए, उसके बाद लिखिएगा. Similarly, secondary amine will be nitrogen with two alkyl groups and one hydrogen. And then we have the tertiary, this secondary, and tertiary will be nitrogen with three alkyl groups attached to it. Okay, so this is ammonia. This is 1 degree, this is 2 degree, and this is 3 degree. Now, all the nitrogen atoms here, they are having a lone pair electron. ठीक है. Now, जिसमें electron density जहां पे ज्यादा होगी, because see the basic nature or basic character is only because of the lone pair electron. Now, if we have a higher electron density, lone pair electron मतलब electron density जहां higher होगा, that will act as a better base or a stronger base. Now, if I look at the electron density criteria, make sense है? सुनो यहाँ पे एक बार हम कुछ आप लोगों से, if the electron density is higher, then the basic character will also be stronger. It will be acting as a strong base. Make sense? Yes or no? Please tell me, guys. Arsalan, Krishna Priya, and Safia.
यस सर।
What about girls? Krishna Priya and Safia.
Yes, sir.
ठीक है. तो now I am going to look at that part कि अगर हम सिर्फ और सिर्फ क्या देखें, if I am going to look only at the presence of electron or the electron density, then we can say that if there is one alkyl group, it will act as plus I group and it is going to give electron density or shift electron density towards nitrogen atom. When we have two alkyl groups, both the alkyl groups will be giving electron density towards nitrogen atom. And when it is 3 degree, all the three alkyl groups will be giving electron density towards the nitrogen atom. And since 1 degree has only one alkyl group, 2 degree has two, and 3 degree has three. So when I'm only looking at the electron density, that is we call as electronic or electronic effects. Electronics. If I'm only looking at the criteria, that is electronics. And in electronics, I'm only looking at what's the plus I effect of the alkyl group. Then in that case, 3 degree will be the most basic, followed by 2 degree, followed by 1 degree, and then the last will be ammonia, because ammonia, it does not have any plus I group. So this will be the order of basic strength. When I am only looking at the electronics, make sense? Yes or no? Please tell me, guys. यहाँ तक किसी को कोई दिक्कत? Any problem till here, guys?
नो सर।
हाँ जी, बताएं. किसी को कोई दिक्कत नहीं ना यहाँ तक? ठीक है, अब ध्यान से देखिए जरा. नाउ देयर इज अनदर इफेक्ट दैट वी हैव टू सी. ठीक है, ध्यान से देखिए. आई एम चेंजिंग दिस. ये अल्काइल ग्रुप इन जनरल था. हम सबसे छोटा अल्काइल ग्रुप दैट इज 1 कार्बन एटम का मिथाइल ग्रुप जो होता है उसको हम लगाते हैं. Now the same methyl group will be attached 2 times here. The same methyl group will be attached 3 times here. ठीक है. Now ammonia can show basic behavior only if this electron pair abstract H plus ion. ये अगर H plus ion पे आके क्या कर सके, अटैक कर सके, तभी जाके वो बेसिक कैरेक्टर शो करेगा. This ammonia also it can show basic nature only if it is able to abstract H plus ion. If it is able to gain H plus ion, abstract H plus ion, ठीक है, then only we will say that it is acting as a base. अब यहाँ पे आप देखिए, this ammonia atom or this 1 degree or this 2 degree or this 3 degree, please imagine the alkyl group as methyl group. Look how big the methyl group is. And when you are going to see the steric effect, the effect of bulky groups, then what you will see that they have different speeds on attacking on H plus. ठीक है, I hope you can see that very easily. आपको दिमाग में आ रहा होगा एक आंसर. Which will be fastest to abstract electron? Tell me guys, only looking at the size. बड़ा साइज ज्यादा स्पीड में मूव करेगा या छोटा साइज ज्यादा स्पीड से मूव करता है, इस बात को सोचते हुए like think on those terms and tell me which will be the fastest to abstract H plus ion. Which will be the fastest? अरे आंसर आना चाहिए. I don't think this is very tough. Tell me. अच्छा ये बताइए कौन ज्यादा स्पीड मूव करता है, बड़ा मॉलिक्यूल या छोटा मॉलिक्यूल? कौन ज्यादा आसानी से मूव करेगा?
छोटा मॉलिक्यूल.
So which will be the fastest to abstract electron? Sorry, abstract the H plus ion. सबसे तेज कौन भागेगा फिर H plus की तरफ? हाँ जी बताएं.
3 डिग्री.
वो सबसे छोटा है. हाँ, is it the smallest? अरसलान
से
नहीं ना, तो इट्स द बिगेस्ट ना. सफिया कृष्ण प्रिया, आवाज क्यों नहीं आ रही है आप लोग? ये नहीं समझ में आ रहा है क्या आप लोगों को?
NH3 तो.
हाँ, NH3 मेक सेंस. कैसे नोट प्लीज टेल मी.
यस सर.
ठीक है, तो अब इसको हम लोग क्या कहते हैं? वी कॉल दैट इट इज द स्टेरिक इफेक्ट. ठीक है, क्या बोलते हैं इसको? स्टेरिक. Steric effect is all the effect that is related to the bulky groups. So if we are talking about the bulky group, Krishna Priya and Safia, make sense na? Ki ammonia will be the fastest to abstract the H plus ion. It will move very fastly and abstract the H plus ion. Yes or no?
Yes, sir.
ठीक है. Now this will be the order: 1 degree, then 2 degree, then 3 degree. Sorry, not 1 degree. Rather, ammonia will be the fastest here, followed by 1 degree, followed by 2 degree, and then followed by 3 degree. Now this is the basic strength if we are only looking at what? If you are only looking at the steric effect. Now as you can see, both of these are giving contradictory or conflicting results. That is why we have to base our conclusion on the experimental data. ठीक है, तो यहाँ पे आप लिखिएगा, if they ever ask you that why this is the order of basicity, then you will say that because the basicity of amines depends on various factors such as electronic effect, plus steric effect, solvation effect. That is why we are having this particular order of basicity. ठीक है, ये आंसर होगा आपको जनरली. हम आपको यहाँ पे लिखा है, since basicity of amines is determined by multiple factors such as plus I effect, steric effect, and solvation effect, which with conflicting results लिखेंगे ना, with conflicting results. Therefore we base our conclusion on experimental data. Base our conclusion on experimental data. Now what is the experimental data? Experimental data is regarding, there are two types of amines that for which we have to remember. एक है आपका इथाइल सब्स्टिट्यूएंट अगर हो, once when you have ethyl substituent, ठीक है, then in that case 2 degree is the most basic, followed by 3 degree, followed by 1 degree, and then followed by ammonia. ठीक है, अमोनिया का सबसे कम रहता है. So if I am going to write in terms of the formula, then C2H5 whole twice NH, one hydrogen will be present. 3 degree में भी C2H5 whole thrice and nitrogen, followed by C2H5NH2, that is 1 degree, and then followed by ammonia, that is NH3. ठीक, now second is we have ethyl के बाद methyl substituent है आपके पास, methyl substituent. ठीक, in methyl substituent also 2 degree is the most basic, followed by 1 degree and then 3 degree and then ammonia. Now in this case I will write CH3 whole twice NH, which is followed by CH3NH2, which is followed by CH3 whole twice nitrogen, CH3 whole twice nitrogen and twice नहीं thrice हो जाएगा ना, my bad, whole thrice nitrogen and then followed by ammonia, NH3. ठीक है, now this is in aqueous medium when you have to abstract hydrogen atom. ठीक है, एक last point आप लिखिएगा, that is in gaseous medium, in gas phase. Now because gas phase में when we talk about gas phase, तो उस टाइम जो acidic और basic nature होता है, we talk about in terms of reaction, है ना, H plus को abstract करने की बात वहां पे नहीं होती है. ठीक है, so when you don't have any H plus ion, तो जब आपके पास H plus ion है ही नहीं और H plus ion के पास जाना ही नहीं है, you don't have to move, then in that case steric effect will not be taking place, only हम लोग electronics को देखेंगे. In gas phase reaction what happens in gas phase, तो लिख लीजिएगा 3 degree is the most basic, followed by 2 degree, then followed by 1 degree. And in the question if they have given anything na, like what will be the basic what will be the order of basic character, basic strength, then you will not consider gas phase. Gas phase अगर हुआ तो वो लिख के देंगे what is the basic strength of the following compounds in gas phase. ठीक है, then this is the order 3 degree, then 2 degree and then 1 degree, whether it is ethyl or methyl, there is no exception here in the gas phase. बाकी ethyl और methyl substitute के लिए these are the orders. Please write this down, raise your hand once you're done. Raise your hand once you're done. ठीक है, एवरीवन डन. ठीक है, अब ना हम थोड़ा सा यहाँ पे मिक्स करके भी आपको बता देते हैं. ठीक है, समझिएगा. देखिए, जहां पे 2 डिग्री की बात आ जाए, ठीक है, सो वी नो दैट 2 डिग्री तो सबसे ज्यादा बेसिक है ही, एक्सेप्ट इन गैस फेज. गैस फेज की हम बात नहीं करेंगे. whenever I am talking in general about basic strength, I will be talking about in the aqueous medium. ठीक है, तो whenever we are in the aqueous medium, तो 2 डिग्री तो ज्यादा है. ठीक है, बट कहीं पे 3 डिग्री ज्यादा, कहीं पे 1 डिग्री ज्यादा है, राइट, आफ्टर 2 डिग्री. So in methyl we have 1 degree that is greater, and in ethyl we have 3 degree that is greater. अब मिक्स करके अगर सवाल आ गया, ठीक है, तो वहां पे कैसे करेंगे हम लोग, तो उसके लिए आप जरा यहाँ पे देख लीजिए. इन जनरल अगर आप देखेंगे, इन जनरल इफ यू आर गोइंग टू लुक, देन वेदर इट इज डाई मिथाइलअमीन और डाई इथाइलअमीन, ठीक है, तो इथाइल सब्स्टिट्यूएंट का इन जनरल ज्यादा है. इथाइल इज मोर बेसिक देन इथाइल अमीन्स, हम ऐसे लिख देते हैं ना, इथाइल अमीन्स. ठीक है, is more basic than methylamines. ठीक है, अगर बात हो इथाइलामीन मिथाइलामीन में, तो इथाइल अमीन जीतेगा. If you are talking about diethylamine versus dimethylamine, then also ethylamine will win. If you are talking about triethylamine or trimethylamine, then also what, triethylamine is going to win. अब इसके बाद एक बार हम एक चीज और बस बता देते हैं लास्ट में. All ethyl amines are more basic than methylamine except dimethylamine. ठीक है, 2 डिग्री की जहां बात आ जाए तो 2 डिग्री सबसे ज्यादा होगा, चाहे वो इथाइलो मिथाइलो, आपको वहां पे फिर और कुछ नहीं देखना, 2 डिग्री सबसे ज्यादा कर देना. ठीक है, इसी वजह से हम एक सवाल करा देते हैं, देन यू विल हैव अ ग्रेटर आइडिया. वेयर इज द बुक? amines 2019 में there was one question 2019 में, and that was a bit confusing question. ठीक है, physical properties नहीं, chemical properties we have to see ना. 2019 C2H5 thrice ethyl नहीं, methyl and ethyl. So ethyl and this is also ethyl. ठीक है. Is there any other question like this? I don't think so. PKB. Here we have ethyl and methyl also. ठीक है, ठीक है, ठीक है, ओके फाइन. देखिए यहाँ पे सवाल है, कैरोटिल विच इज मोर बेसिक है ना बिटवीन दीज टू. ठीक है, सो अब ये बताइए, अब यहाँ पे कोई तो डाई नहीं है. दिस इज व्हाट 3 डिग्री एंड दिस इज 1 डिग्री. ठीक है, अब आपको देखना है कि इथाइल और मिथाइल कौन. दिस इज व्हाट, दिस इज मिथाइल एंड दिस इज व्हाट, दिस इज इथाइल. मेक सेंस? इस प्लीज टेल मी.
यस सर.
यहाँ पे कौन ज्यादा होगा, इथाइल या मिथाइल? इथाइल. मेक सेंस? याद रहेगा ये ना. ऑल इथाइल अमीन्स आर मोर बेसिक देन मिथाइल अमीन्स एक्सेप्ट डाइमिथाइल. डाइमिथाइल आ जाए तो नहीं देखना है. ठीक है, डाइमिथाइल तो डाइमिथाइल ज्यादा होगा. ठीक है, लेकिन डाइमिथाइल अमीन के डाइमिथाइल अमीन और डाइइथाइल अमीन में इथाइल जीतेगा. ठीक है, सो आपको विनर इथाइल को रखना है एक्सेप्ट व्हेन यू हैव डाई. डाई वर्सेस 1 डिग्री और 3 डिग्री आ गया. ठीक है, तब तो डाई जीतेगा, डाइमिथाइल. अदरवाइज इट इज ऑलवेज इथाइल अमीन. यू गॉट दिस गाइस? यस और नो प्लीज टेल मी. 2 डिग्री होता तो 2 डिग्री को पहले देते. ठीक है ना, बट लाइक दिस यू हैव टू गिव इथाइल फर्स्ट. ठीक है, अगर हम इस तरह से बात करें तो देखिए, जो आपके पास ओवरऑल ऑर्डर आएगा ना, देन द ओवरऑल ऑर्डर इज गोइंग टू बी 2 डिग्री इथाइल. ठीक है, 2 डिग्री इथाइल. उसके बाद आएगा 2 डिग्री का मिथाइल. ठीक है, 2 डिग्री इथाइल अमीन, उसके बाद 2 डिग्री मिथाइल अमीन. आफ्टर दिस 2 डिग्री इथाइल एंड 2 डिग्री मिथाइल वी विल हैव 3 डिग्री का इथाइल. में कौन पहले आता है? 3 डिग्री ना, हाँ, इथाइल. 3 डिग्री का इथाइल. ठीक है, उसके बाद आएगा 1 डिग्री इथाइल. ठीक है, आफ्टर दिस वी हैव मिथाइल. मिथाइल में कौन पहले आता है? 1 डिग्री. आफ्टर दिस विल हैव 1 डिग्री मिथाइल और एंड में आएगा आपके पास 3 डिग्री मिथाइल. ठीक है, दिस इज द ओवरऑल ऑर्डर. ठीक है, अब इसको भी लिखना तो लिख लीजिए आपको. Now, after this, you'll write point. Amines are more basic than ammonia due to plus I effect of alkyl groups. सफिया, आपका प्रैक्टिकल हो गया?
केमिस्ट्री सर?
या केमिस्ट्री?
नहीं, मंडे।
अच्छा, मंडे है। कोई भी प्रैक्टिकल हुआ अभी तक?
हाँ, 2 है।
अच्छा, फिजिक्स हो गया?
हाँ, आज फिजिक्स हो।
सो व्हाट डिड दे आस्क?
वाइवा,
वाइवा में?
करंट, इलेक्ट्रिसिटी, सेमीकंडक्टर्स और लाइट।
अच्छा, they like did they ask you like what chapter have you prepared or something like that?
नहीं नहीं, मतलब जो एक्सपेरिमेंट दिया था उसमें अगर करंट इलेक्ट्रिसिटी का एक्सपेरिमेंट है फिर उसके बेसिस पर था।
Okay. But I think Eram को वैसे नहीं पूछा था शायद. Eram was asked regarding you have met Eram, right?
यस सर।
उसको are you guys on in the same section or different sections?
नो, डिफरेंट डिफरेंट।
Uh, so she was asked regarding the project first of all,
हाँ
and then in general she was asked regarding some chapters,
हाँ,
as she said. Yeah.
मतलब एक्चुअली सेम वही, उन्होंने पहले पूछा कि क्या प्रोजेक्ट है, फिर उस
अच्छा.
पे थोड़ा, उसके ऊपर थोड़े क्वेश्चन एंड देन फिर एक्सपेरिमेंट पे थोड़े क्वेश्चन।
Okay. कैसा गया? बायो भी हो गया आपका?
नहीं, बायो कल है।
अच्छा, बायो कल है. ओके. कैसा गया फिजिक्स?
फिजिक्स अच्छा था।
गुड. होपफुली ऐसे ही हो जाए सब कुछ धीरे धीरे. ऑल ऑफ यू डन? असलान, कृष्ण, प्रिया, सफिया?
यस सर।
यस.
Right, next we are going to compare aniline versus amines versus ammonia. ठीक है. Now, aniline, what is aniline? Aniline is benzene ring that is connected directly with NH2. Now, this nitrogen atom, it is having a lone pair electron which has to attack on the H plus ion. But that is not possible, or rather this lone pair will not be available. Why? Because it is taking part in resonance. So rather than attacking on H plus ion, it is what? Taking part in resonance. That is why this lone pair electron is not available. And hence aniline is less basic than amines. ठीक है. Amines क्या? They are even less basic than ammonia, because ammonia may be delocalized. We have a localized lone pair. यहाँ पे lone pair is what? It is delocalized. So we'll write aryl amines. Now in aryl amines everything is inside aryl amines, है ना? चाहे वो for example para substituted कुछ हो, ortho substituted कुछ हो, कुछ भी हो aryl amine. So all the aryl amines, including mainly aniline, are less basic because the lone pair electron on nitrogen atom is delocalized due to resonance. Due to resonance and not available to act as, or actually not available to attack on stress. ठीक. Right, next aryl amines are even less basic than ammonia. ठीक है. But so in general हमारे पास क्या है? We have 2 डिग्री, 2 डिग्री अमीन सबसे ज्यादा बेसिक, ठीक है, 2 डिग्री सबसे ज्यादा है ना। उसके बाद बाकी बाकी ऑल दी अदर अमीन्स, ठीक है, बाकी अमीन्स बाद में आएंगे। एंड आफ्टर अमीन्स वी हैव अमोनिया NH3 एंड आफ्टर दैट वी हैव एनिलीन, ठीक है। बट इफ यू टॉक अबाउट the basicity of aniline, can it be changed? Yeah, so basic nature can be basicity of aniline will increase if we are going to add a electron donating group. We add an electron donating group, for example CH3, OCH3, etc., and it is going to decrease if we add a electron withdrawing group, है ना? One of the most important one is NO2, CHO, इस तरह की चीजों को अगर हम ऐड करेंगे, ठीक है। सो राइट दिस डाउन। डन गाइस, आई होप यहाँ तक आपका हो गया कम से कम। You can write this question now.
Sir, can you scroll a bit up?
Yeah, sure, no problem. ठीक है इतना?
Yes, sir. Yes, sir, you can scroll down, sir.
No, no problem. आप लोग लिख लीजिए आराम से। हाँ, डन गाइस।
Yes, sir.
सवाल लिखा आप लोगों ने?
Yes.
Arrange the following in increasing order of their basic strength, है ना। सबसे पहला क्या है हमारे पास? फर्स्ट नंबर में वी हैव C6 H5 NH2 जो कि है एनिलीन, ठीक है। देन वी हैव C6H5 NH2 CH3 whole twice, ठीक है। That means we have benzene ring like this, जिसमें कि we have nitrogen and this nitrogen has 2 CH3 groups, ठीक। so this is still aniline but इसमें CH3 लगा हुआ है, और rather I should say this what aniline which is what having 2 CH3 groups, है ना। उसके बाद है आपके पास C2H5 NH2, so it is C2H5 whole twice NH, that means it is what 2 डिग्री, ठीक है। इसके बाद कौन सा आएगा? CH3NH2, CH3NH2, दिस इज 1 डिग्री, ठीक है। सबसे ज्यादा बेसिक कौन होता है? 2 डिग्री। सो इफ आई लेबल दिस एज A, B, C एंड D। सबसे पहले तो अमीन्स आएंगे, तो अमीन्स में सबसे पहले कौन आएगा? C आएगा, एंड आफ्टर दैट अमीन कौन है यहाँ पे? D है। देन दी रेस्ट आर एनिलीन। एनिलीन में भी B will be more basic because CH3 will be giving electron density, तो उसके बाद आएगा आपके पास B, and then A will be the least basic, that is aniline. सेकेंड में आपके पास है वी हैव C2H5 NH2 उसके बाद है C6H5 NHCH3 C2H5 whole twice NH and C6H5 NH2. ठीक है, so if this is A, this is B, this is C, this is D. So this is simple 1 degree amine. This is aniline. This is 2 degree, and this is aniline once again. ठीक है, but since this aniline is having CH3 group, so it will be more basic than the normal aniline. यहाँ पे भी सबसे ज्यादा क्या होगा 2 degree, that is C. After that amine is A. Then you will look at aniline. Aniline में substituted aniline will be more basic, that is having CH3. So that is why we will be having B, and then we will be having the pure aniline, that is D. Now this is the order of what? Basic strength. They're asking about the pKb values. So the pKb value will be the same things, but the sign will change, है ना? तो sign change कर देना है बस आपको. This will be the pKb value, because basic strength and pKb values are inversely proportional. If it's down, raise your hand once you're done. Just waiting for Arslan now. Okay. Now, at the last reaction, that is electrophilic aromatic substitution of aniline. Electrophilic aromatic substitution of aniline. Now, since the NH2 group, it has a lone pair electron, and that is why it is highly activating. At NH2 is highly activating. And ortho, which is highly activating, and ortho para directing. Ortho para directing due to strong plus M effect. ठीक है, so it is going to give you ortho and para substituted products. ठीक है, now the first reaction that we have to see is bromination in this particular case. A is bromination. ठीक है, now in bromination we have NH2 and we just need to add bromine aqueous. ठीक है, Br2 aqueous. When we add Br2 aqueous, then it is going to give me tri-substituted product. NH2 here, both the ortho positions are attached with bromine and the para position is also attached with bromine. So this is 2, 4, 6 tribromo aniline. 2, 4, 6 tribromo aniline. ठीक है. Now this is the problem because we do not always give or rather require tri substituted product. तो पहला चीज तो आप यहाँ पे लिखेंगे it gives tri substituted product on bromination due to strong plus m effect. Due to strong plus m effect. हाँ. अब इसके बाद how can we get, another question is, another जो अगला सवाल आ सकता है, एक सवाल ये आएगा, why do we get tri substituted product due to strong plus m effect. अगला सवाल जो आपके पास आ सकता है that is how can we get mono substituted product. ठीक है. So उसके लिए प्लीज राइट to control highly activating nature of NH2 and get mono substituted product acetylation of aniline is done. Acetylation is of aniline is done, है ना. We do acetylation. ठीक है. तो आपके पास सवाल आ सकता है why do we do acetylation. Then you will like to control, और ऐसा सवाल आ चुका है, to control highly activating nature of NH2 and get mono substituted product. What is acetylation? We have benzene ring attached with NH2. This is reacted with acetic anhydride. What is acetic anhydride? CH3 C double bond O, oxygen C double bond O and CH3. In the presence of, we use pyridine as we have seen in the previous lecture. हम लोगों ने देखा था that when you are going to react with any of these things, ठीक है ना, acyl chloride, acetic anhydride या फिर ethyl ethanoate, ठीक है, then you will get acetylation. So what happens then? We have the benzene ring as it is, the nitrogen atom is as it is. अब यहां से एक हाइड्रोजन निकल के एक हाइड्रोजन बचता है, and this nitrogen atom, it is directly bonded with C double bond O and CH3. So this acetyl group has been attached. ठीक है. This nitrogen atom is still having lone pair electron. Lone pair electron has not gone anywhere. And after this, when you are going to add bromine, now obviously you can see the ortho position is what? It is sterically hindered. CH3 is here. So ortho position is not anymore, it is reactive, but it is not accessible. So ortho position, there will be no bromine attached. The bromine which will be attached is on the para position. And this nitrogen H C double bond O CH3 will be as it is like this. And यहाँ पे आपके पास क्या आ गया? Para position में Br. Now, in order to re-get the NH2, we just need to do hydration H2 in the presence of H plus or OH negative, and you will regain the aniline. NH2 मिल गया आपको, and you will get the Br position here. ठीक है. तो अलग अलग सवाल है ना. Why do we get tri-substituted product? Due to strong plus M effect. Why do we do acetylation? To control the highly activating nature and get mono substituted product. Now, the other question that can be asked is why acetylation of aniline gives mono substituted product. ठीक है. Acetylation करने से ऐसा क्या हो जाता है? ठीक है. So that we are going to answer now. Right. The third point, after acetylation, is right after acetylation, the lone pair electron on nitrogen atom interacts with carbonyl group due to resonance. due to resonance, and hence makes lone pair electron less available for benzene. ठीक है? And if it is less available for benzene, it will not go to benzene. And if it is not going to benzene, it will decrease the activating nature. This decreases the activating nature leading to formation of monosubstituted product. ठीक है? होता क्या है देखिए, दिस इज द बेंजीन रिंग, द नाइट्रोजन इज अटैच्ड हियर, एक हाइड्रोजन इसके पास है, एंड दिस नाइट्रोजन एटम, लेट मी जस्ट make it a bit clear. Nitrogen atom, the hydrogen is here, C double bond O, CH3, this lone pair electron. Now this lone pair electron, it was going to benzene ring, and that is why it is showing resonance and increasing the electron density there. But now it can also show resonance with this carbonyl carbon, and as it shows resonance with the carbonyl carbon, it is less available for the benzene ring. ठीक है? आपने यहाँ पे ऐसे लोन पेयर दिखा दिया, और उसके बाद ऐसे करके लिख दीजिएगा, लेस अवेलेबल ठीक है, लेस अवेलेबल फॉर बेंजीन. ठीक है, छापिए जरा. ये तीनों समझ में आया ना आप लोगों को पॉइंट्स? लाइक अलग अलग सवाल आ सकते हैं. ठीक है, छापिए जरा. हाउ कैन द एक्टिवेटिंग नेचर ऑफ NH2 ग्रुप इन एनालिन कैन बी कंट्रोल? टू कंट्रोल, ये आपके पास आंसर आ गया है ना. इसके बाद रुके और आपको दिखाते हैं. देखिए ये अगला सवाल एक है. गिव रीजन एसिटाइलेशन ऑफ एनिलीन रिड्यूसेस इट्स एक्टिवेशन इफेक्ट. ठीक है, तो उसका ये आंसर होगा. आफ्टर एसिटाइलेशन व्हाट हैपेंस. ठीक है, आई मीन देखिए बहुत क्या है, ये दोनों चीजें सिमिलर लगेंगी आपको, बट यू हैव टू गिव डिफरेंट आंसर्स फॉर देम. डोंट हैव टू राइट द क्वेश्चंस, बट आई एम जस्ट शोइंग यू गाइस, है ना, कि किस तरह से पूछा जा सकता है. पूछा जा सकता नहीं, पूछा गया है मतलब. ठीक है, रेज योर हैंड वंस यू डन. ठीक है, अब इसके बाद है नाइट्रेशन। नाइट्रेशन, ठीक है। नाइट्रेशन में आपके पास एक जो सवाल आएगा, दैट इज डायरेक्टली फ्रॉम द रिएक्शन. So when we do nitration of aniline, since NH2, it is what? It is a ortho-para-directing group. In the presence of HNO3 and concentrated H2SO4, we are expecting a ortho-substituted product with NO2 in the ortho position, and we are expecting a para-substituted product with NH2 and NO2 in the para positions. But we get a significant amount of meta-substituted product also. We have NH2 here, and we have NO2 here in the meta substituted product also. And it is also not very less. जो आपके पास ortho substituted, that is very less, that is 2% only. The para substituted is 51%, and the meta substituted is significantly 47%. So it is a quite high percentage that we are having, ठीक है, of meta substituted product. अब ये सवाल आता है, why even though NH2 is OP directing, but still it gives a significant amount of meta nitro products? Why? So we will write here, in presence of concentrated acids, both H2SO4 and HNO3 are what? Concentrated acids. The NH2 of aniline gets protonated and becomes NH3 positive. ठीक है, NH3 positive, which is, now since we are having positive charge, it will pull electron density, making it deactivating, which is deactivating and meta directing group. ठीक है, meta directing group. Therefore nitration of aniline gives significant amount of meta nitro aniline. ठीक है, टू गेट मोनो सब्स्टिट्यूट या फिर वही पैरा, टू गेट ओनली पैरा नाइट्रो aniline, acetylation is done. ठीक है, तो आपके पास वही सेम NH2 एसिटिक एनहाइड्राइड. जनरली ना यहाँ पे आपको pyridine दिख जाएगा, pyridine के प्रेजेंस में करने से दिस इज क्वाइट फास्टर. ठीक है, so pyridine, it is not acting as any reagent type of thing, but it shifts the equilibrium on the right side. So we'll have NH, C double bond O CH3. After this, we are going to add conc HNO3, conc H2SO4. This will give you nitrogen. The hydrogen is as it is. Double bond O CH3 is as it is. In the para position, you will get NO2. Further, in the hydration, in the presence of H plus or OH negative, this is going to give you the NH2 group back, and the nitro group will be as it is. ठीक है, so please write this down. Raise your hand once you're done. लिख लिया क्या आप लोगों ने? अच्छा, ऑल ऑफ डन, ठीक है। इसके बाद लिखिएगा सल्फोनेशन। So what is sulfonation? Sulfonation में we use concentrated H2SO4. When we use concentrated H2SO4, we first of all get a salt, that is H from H2SO4. It attaches to the nitrogen atom, making it NH3 positive. And what is remaining from here is SO3H, negative charge. And after a lot of heating from 453 Kelvin to 473 Kelvin, okay? So after a lot of heating, what happens? We get a para substituted product, that is NH2 is in the, and SO3H, both of these are in what? In the para positions. इसको बोलते हैं sulfonilic acid. The name is important because sulfonilic acid and also the structure that we have got after the protonation of nitrogen once again. The sulfonilic acid, the hydrogen is what it is acidic in nature, and the nitrogen's lone pair, because of its lone pair, it is basic. So it gives a reaction in which hydrogen of one sulfonilic acid is attached to the nitrogen of another, and we get a Zwitterion type of condition, that is nitrogen, it has 3 hydrogen with a positive charge, and the SO3, it is having a negative charge. Now this is the Zwitterion form of sulfonilic acid. ठीक है, this is Zwitterion form. Zwitterion क्या होता है? A compound which is having positive and negative, both the charges in one molecule. ठीक है, this is the Zwitterion form. Now, the Zwitterion form of sulfonilic acid has been asked once. You have to show what is the Zwitterion form of sulfonilic acid. ठीक है, so this is very important. The name is also important, so that you should know what is sulfonilic acid and the Zwitterion form also. After this, you will write last point regarding the electrophilic aromatic substitution. A note not inside sulfonation, a general note regarding electrophilic aromatic substitution of aniline is aniline does not show Friedel-Crafts reactions. Friedel-Crafts reactions का मतलब both alkylation और acylation दोनों ही नहीं शो करता है. Why? Due to the formation of, अरे क्या लिख दिया हमने, ये aniline लिखिएगा साफ साफ जरा. I wrote it with a spelling mistake. Aniline. ठीक है. Due to the formation of with Lewis acid AlCl3. Lewis acid AlCl3. And you write due to this nitrogen atom gains a positive charge which strongly deactivates the benzene ring, and further reaction isn't possible. Further reaction is not possible. Okay. If you want to write the salt, then you can write the salt also. We have NH2. Here we are going to have AlCl3. So this nitrogen atom has lone pair. Aluminium atom, it is having a vacant p orbital. Okay, it is only making 6 bonds. That is why कम ऐसे शो कर देते हैं यहाँ पे नाइट्रोजन एंड इट इज हैविंग 2 हाइड्रोजन्स H2. इसके लोन पेयर से it is going to form a bond with AlCl3. So it is bonding a form with aluminium chloride. AlCl3 like this. A dative bond, a coordinate bond. तो जो एक सेकंड हो जाए जरा इसको हम ऐसे लिख देते हैं. This nitrogen atom, it is having what? एक सेकंड. NH2 और साथ में एक बॉन्ड बना रहा है किसके साथ? AlCl3 के साथ. So this nitrogen atom will get a positive charge. Lone pair is not available now. ठीक है, अब यहाँ पे लोन पेयर नहीं बचा. क्या बचा? सिर्फ पॉजिटिव चार्ज बचा. AlCl3 will have a negative charge here because it is getting an electron. ठीक है, इस तरह से पॉजिटिव चार्ज आ जाएगा. That is why it becomes deactivating. Okay. Arslan, Safyan, Krishna Priya got this? Yes or no?
Yes, sir.
Yes, sir.
तो आज के लिए इतना ही. Tomorrow we will be completing this chapter. There's a small portion left that is regarding diazonium salts. And tell me guys, what chapter should I start next? See, solutions we are doing in Monday, Wednesday वाले batch में ना? Yes or no? Monday, Wednesday solution है ना? तो
Yes,
क्या
sir.
स्टार्ट कर? यहाँ पे क्या स्टार्ट कर दे? केमिकल काइनेटिक्स और इलेक्ट्रोकेमिस्ट्री. Tell me guys.
Chemical kinetics.
Chemical kinetics, Safia, Arslan.
Okay,
जी
sir.
बताएं. Okay, ठीक है. So we'll be starting chemical kinetics hopefully from tomorrow itself. Okay. चलिए, thank you guys. Thank you very much. Bye bye. Take care.